Good morning, everyone. Dear colleagues, let me introduce myself and my investigation. My name is Svetlana Vynokurova, and I am a PhD student of Melitopol State Pedagogical University. I want to present the results of assessment of the saline biotope state of the North-Western Pryazovia as breeding sites of Glareola pratincola with the help of remote sensing data. This investigation intersects two themes, two rare objects. There are a rare species of bird, Glareola pratincola, and its main habitat, salt marshes, which are also limited and segmented. Glareola pratincola is a species protected by a number of national and international conventions. It is in Rare Book of Ukraine with the status rare, listed in Appendix 1 of Bird Directive of European Union, protected by Bern, Bonn, Iowa conventions. The numbers of Glareola pratincola have decreased last time. According to data of synchronous counts in 1998, in Azov Black Sea region, their numbers were 1,135 pairs. According to the information in Rare Book of Ukraine, in 2009, there were just 400 pairs there. Glareola pratincola chooses for breeding mainly saline biotopes, like salt marshes, saline meadows, etc. These biotopes are very vulnerable to abiotic and biotic and anthropogenic factors. In particular, climate change is one of the factors that influence on feature of saline biotopes. I wanted to estimate what kind of biotopes Glareola pratincola needs and what states of salt marshes in my area of interest. And the next question, is satellite monitoring able to estimate the state of salt marshes? So my area of interest is North-Western Pryazovia. Why North-Western Pryazovia? The first, because of importance this place for breeding Glareola pratincola. According to our previous investigations, there is the second important place for Glareola pratincola in Ukraine. The first is Sivash. And the second, because of big areas of the salt marshes in the coasts of the months in the northwestern area. By preliminary assessment, there are at least a quarter of all saline biotopes from all Azov Black Sea region there. You can see on the slides what kind of methods I used for this investigation. I will not describe them in details, but I consider them in details in my article, which will be published in the proceeds of this conference. I want just to pay your attention that I used the soil sample and drawn for verification some of the results. So let's consider these results. Distribution. Again, I estimated both current distribution of Glareola pratincola and distribution of salt marshes. Field investigation was used in first case, and random forest classification of satellite images was used for definition of salt marshes. 93 sites of saline biotopes were determined. 44 of them, but there are 81% of total area were investigated during the expedition and verified. 12 colonies of Glareola pratincola were found. The biggest by area, salt marshes, were located in Tobalsky Liman. But there is no significant relationship between area of salt marshes and number of Glareola pratincola. Moisture. 9 water content indexes were calculated. All of them were compared with results of field soil sample analysis. The most effective were indexed based on the value of near and middle infrared spectral bands. There are moisture stress index and normalized difference moisture index. I described the MSI just because of positive correlation, and the MI has negative correlation. This parameter is quite dynamic. Thus, Glareola pratincola used salt marshes with a wide range of moisture, in the range from 13 to 33%. 5 vegetation indexes were calculated for estimation vegetation cover. All of them were compared with data that were received from the drone. All calculated indexes showed a statistically accurate correlation with the value of the actual vegetation cover. According to literature, Glareola pratincola used the habitat that vegetation cover not more than 35%. But our investigation demonstrates that it can be significantly up to 66%. Glareola pratincola is a ground breeding species, so surface temperature is an important parameter during the egg laying period. By my estimation, the average surface temperature of saline biotopes in June is around 34 degrees Celsius. For comparison, the average temperature for other land areas within the basins of the Azov liman's was 2 degrees below. So, presumably, Glareola pratincola chooses warmer parts of the soil as a breeding habitat. According to literature, colonies of Glareola pratincola located in certain proximity of water sources. But what does it mean, certain proximity? In North-Western Pryazovia, all considered saline areas suitable for nesting were located directly near water area. The average distance from the found colonial settlements to water body was 130 meters. In relation to freshwater source, like river, channel, or well, as you can see on the slide, the most settlements located less than 50 meters from fresh water, but 2 colonies were located more than 10 kilometers from the source of fresh water. The disturbance factor was assessed both from indirect data, the distance to potential source of such a factor, and from the fixation of the direct facts of grazing, recreation, etc. Average distance to village was approximately 2 kilometers. It should be noted that place of the colony that turned out to be closest to the settlement in the past was a stable breeding place, Glareola pratincola. Its colonies have been recorded here from 2000 to 2013, mostly annually. Distance to road was also around 2 kilometers. Direct factors. During the period of expeditionary research, there were recorded 9 facts that were assessed as a possible impact on the Glareola pratincola colonies. Grazing, beach recreation, and metafishing. In the only colony which was located less than 1 kilometer from the place of grazing sheep, no birds or nests were found then revisiting. So I had 3 questions in the start of this investigation. What kind of answer I received? Ability of using satellite imagery. Remote sensing data objectively reflect the current state of the saline biotopes, like the state of soil moisture, vegetation, and surface temperature. Glareola pratincola requirements for habitats. There were received values of some habitat characteristics. In more cases, a wide range has been identified. So the obtained data is a start point for further monitoring of breeding site of Glareola pratincola, as well as for further assessment of its ecological niche. State of salt marshes. Based off 95 confidence interval of each of the analyzed parameters, 67% of the saline biotopes in the region meet the eligible criteria. It can be assumed that unoccupied areas include both sites that meet the needs of the species, but not occupied due to the small number of breeding pairs, and sites not suitable for breeding. But this assumption needs further verification. So, except the answer for some questions, I received the new questions that stimulate new investigations. For example, possible not only estimation of vegetation cover is important, but also the structure of vegetation, plant height, which contributes to the protection of chicks. Further research is also need to clarify the impact of other disturbance factors, including non-anthropogenic. And the next step is assessment of suitable habitats via species distribution model methods. I am sincerely grateful to Joseph Ivanovich Chernichka for participation in field research and valuable comments on the manuscript. I also thank European Space Agency for possibility to use satellite images for free, and Google Corporation for their beautiful product, Google Earth Engine, that is really useful. And many thanks for Society for Conservation GIS and ESRI for ArcGIS license that I used during my analysis. Thank you for your attention. It is really important for me to present these results. And I really hope that this result will help to preserve these beautiful birds, colored pratincola, the chick of which you can see on the screen. Thank you.